We're going to talk about the volume of pyramids and cones. The idea is we're going to compare these to the relationships that exist with the cylinders and the prisms that we just talked about. And the idea is that if you notice a prism has one base and a second base, where a pyramid only has one base and then this vertex at the very top. If we have the same bases and the exact same height, is the prism going to contain more or less volume than the pyramid? Well, the prism is going to contain more. And the question is exactly how much volume will the pyramid have? We can kind of look at a very similar idea over here, that if you take a cylinder, this is the outside piece, and stick a cone on the inside, it looks like you could almost fit like another cone like over here, and yet another cone over here. And in fact, that's true, is that a cone is only going to take up 1/3 the volume of a cylinder. And the same thing is actually true for a pyramid, that it takes up exactly 1/3 the volume of its associated prism. So the idea here is that if B is the area of the base and H is the height, and usually I'll use this as a lowercase h, and the formula is simply going to be volume equals 1/3 the area of the base times the height. Some people will choose to write this way. They'll say capital B times H divided by 3. And then specifically when you're talking about a cone, some people, because the base is a circle, will say pi r squared h and divide all that by 3. All three of these formulas do work for cones. Specifically for a pyramid, you'd have to use one of these two, and all three of these are equivalent for a cone. Let's take a look at some examples really fast. Again, this is a pyramid. Specifically, I would call it a square pyramid because the base is a square, so it's a square pyramid. And the area formula or the volume formula is 1/3 the area of the base times the height. So we'll say 1/3. The area of our base is 8, and we'll have to square it. We'll multiply this by the height of the prism. This should give us, when we multiply this out completely, that should give us 192 cubic units. Okay, again, you need to identify what is the base, find the area of that base, and then we'll just go through and we'll multiply from there. On this side, we'll say this is a cone, so volume equals, again, 1/3 the area of the base times the height. Specifically, we could write this as pi r squared h divided by 3. That would give us, let's see, that's pi. Our radius in this case is 6 squared. Our height is 7. We'll divide that by 3. That would be equivalent to, let's see, that would be 36 divided by 3 is 12 times 7. This would be 84 pi cubic units. And probably we would use the decimal representation. It's somewhere around 163. We'd probably round in the nearest tenth cubic units. Let's check these out really quickly. When we deal with a triangular pyramid, again, it's going to tell us what the base is. So we'll say volume equals 1/3 the area of the base times the height. That'd be 1/3. We have to use the formula for a triangle. That's going to be 1/2 the 6 times the 8. And we'll multiply by the height of the pyramid, which is going to give us 20. 6 times 8 is 48. Divide that by 2. We're going to get 24. Divide that by 3. We would get 8. 8 times 20 should give us 160 cubic units. Over here we have a cone. This is going to be volume equals 1/3 the area of the base times the height. In this case, that's going to be pi r squared h divided by 3. For us, it's going to be pi times 2.7 squared times a height of 12. We'll divide that by 3. 12 divided by 3 is 4. We'd have 4 pi. 4 pi times 2.7 squared. I can't really remember what that is. Maybe somewhere around 91.6 cubic units. Something like this. Okay, this last one, we have a rectangular prism. So this area of our base is going to be a rectangle. So it's going to be 1/3 the area of the base times the height. Remember, this is a rectangle, so we'll say that's going to be 7 times 3. And we'll multiply that by a height of 11. 7 times 3 is 21. Divide that by 3, we have 7. 7 times 11 is 77. We have 77 cubic units. The only way they can really make this harder is they can change the bases. Instead of making a base that's maybe a rectangle or a simple triangle, they could use a trapezoid. They could use regular polygons, or they could even use something even more complicated, such as a composite figure or something else. Another thing they could do to make this a little bit more difficult is they could actually make you work the problems backwards, or calculate some of these values, such as the height. They might give you the slant height and the radius, and you have to actually calculate the height, probably using the Pythagorean theorem, which is hypotenuse squared equals leg squared plus leg squared. A couple of variances they could give you. Just make sure to check it out. Remember that the formula for us is always going to be 1/3 the area of the base times the height.